My name is Hadi Hanger. I'm from the German Aerospace Center. At this booth, you can see few more use cases of simulation. You've seen perhaps in the talk where 3 demonstration simulation use cases were presented. They are also presented in detail at other booths. But here are some further advanced use cases of simulation which build on the fundamental functionality of set-level simulation toolsets, namely performing simulation runs and having standardized interfaces for input and output. So, the first use case, it is at the beginning of the development process where you got, some idea of the functionality of your car and you want to identify criticalities, that is, critical scenarios which should be studied in further stages of the development process. And for that, we couple, genuine set-level simulation tool, namely OpenPath, for identifying critical scenarios, with another simulation tool which generates traffic. So, in this case, we've taken the Sumo tool, which is a traffic flow generation tool, and taking one crossing, we let Sumo generate the traffic at the crossing, and then once Sumo has generated some situation, we let OpenPath take over and do a very detailed analysis of what happens from that situation onwards. And if OpenPath, which is capable of doing criticality studies, has identified some interesting situation which evolves in a potentially critical scenario, then this scenario is stored for future analysis in the other stages of the development process. And then these tools are coupled. Sumo gets the results of the OpenPath simulation and continues with its flow generation and so on. And from time to time, OpenPath takes over and then does again a detailed analysis. So this is one example of how you can use the standard interfaces of OpenPath to interface it with another simulation tool for some interesting functionality. Okay, this was at the beginning of the development process. The other 2 use cases I'm going to present concern the last stage or even the stage after that. We come to that. Imagine you've got your automated vehicle more or less finished and you've got a good model of it, so you can do a very faithful simulation of its behavior and traffic. Then you might want to compute or evaluate the risk which is incurred with bringing this vehicle into traffic. We all know we have to provide some kind of evidence that the vehicle is safe enough. So here's the sketch of a procedure which computes the risk coming from the scenario, from the automated vehicle in a particular logical scenario. Here we got 2 parameters of a logical scenario, and what you see here is the graph of the unknown risk function, which you can compute at each parameter combination, but you want to compute the integral over the risk. Then what we do is like a Riemann integral computation. We choose samples, look at what comes out, and from that on we combine all the results, sum all of the identified risk up, and get an estimation of the risk which is incurred by the automated vehicle in this scenario. For this use case to realize, you need a lot of things, like a very faithful model of your system a very good estimation of the risk in one particular simulation run, and then you can design a procedure which does just like that. And you see that the samples get more and more if we see some significant risk, and the samples get less in the uninteresting regions. So this is a very ambitious application of simulation, but a very interesting one. So, and it can, of course, be implemented on top of a standard, genuine set-level simulation tool, again by using the standardized interfaces and programming a higher order procedure which uses the simulation. Now, for the third use case, consider you've got your automated vehicle brought into traffic. Then, what you have to do is to monitor this vehicle or the fleet of vehicles for incidents, for potential critical situations, which, well, indicate that your automation could still be improved. And this you do by having a monitor in the car which looks for potentially critical situations, records them, and then, then you're going to analyze these recordings. And again, you can profitably use simulation by translating your recording into a simulatable form using OpenScenario and OpenDrive, and then letting run a detailed analysis of the situation and variations thereof. By that, you get a handle on what happens with your car in real traffic and what are potential flaws in your automation you should improve upon for the next update. So, let me return at the overview. I've presented 3 use cases for simulation within the development process at different stages, in addition to the demonstration simulation use cases, which you can see at other booths and another talk. So, and of course, there are hundreds of usages of simulation of this type or other types, which can be implemented, and for all of that, the flexibility, modularity, and standardized implementation of the set-level simulation tools will help you to implement them rather smoothly and easily. So, have a look at these details. Thanks a lot for your attention.